Welcome, everyone, for yet another episode of Hanger DX. Today with us, we have Eric. Eric joining us from Asana. Eric, really excited to have you today in our DX session podcast. So, why don't you start with maybe introducing yourself, what you do at Asana, and we'll go from there.
Yeah, thanks so much. Super excited to be here and to chat. I've been at Asana for about 3 years, thinking a lot about build systems and developer productivity. I've always been really excited about platform engineering and really just think there's so much, both technically interesting things, but so much leverage in kind of building great platforms that enable other developers to thrive. So whether that's thinking about it from the build systems perspective or other kind of areas of developer experience, yeah, really love building for developers as the customer.
All right, so maybe we can start with every company describes platform engineering slightly differently. So, give us a bit of perspective of how does Asana think about platform engineering as a whole.
So we holistically think about platforms through our foundations org. And this encompasses a pretty wide scope, even a larger scope than you might imagine at some other companies. So this is everything from design systems to how engineers are writing their code to observability and things around getting code into production. So it's really a huge gamut from the software development lifecycle piece that we kind of typically think about developer experience to the whole lifecycle of managing code until it's released to customers.
Are there like different teams dedicated for different parts of developer experience? And is it kind of like, would you know, like roughly the scale of like how big is this team is, how many engineers is it serving in Asana?
So we have teams staffed both thinking about the software development lifecycle. So this is like build, test, release, deploy. Teams staffed around the frameworks of how engineers write code. So what are the building blocks, both on the front end and back end, that engineers are using to write code? We have teams staffed around the infrastructure, around how our code runs in production. And overall, we're serving hundreds of engineers as our customers that are using our systems and tools every day.
So, like, how do you think about roadmap planning? What are some of the key areas that you particularly look for? And also, if you can share a perspective of developer experience as a whole at Asana.
So within building platforms, there's a huge variety of metrics and KRs to think about. Specifically in the piece around the software development lifecycle, there's a couple KRs that we focus on, but really there's no perfect answers here. And our opinions of what is the important thing to measure has also changed a lot over time. So right now, the kind of main things we focus on first is cycle time. So how long does it take from an engineer opening a pull request until it is deployed in production? So we think about this as how long does it take us to get user value out of the code that engineers are writing? You can imagine if an engineer puts up a pull request and it takes forever until it gets merged and forever until it gets released, that's probably not great. So cycle time is the first key metric we think about. The next thing we think about is local iteration time. So how long does it take engineers to locally build, compile, and test their changes? So things like local build times, how long does it take to write tests, all kind of factor into this local iteration experience. The next one is maybe a little bit surprising, but we think about crash rate. So how many users are experiencing crashes in production? And so we think of quality as also a big part of the measure of success of our platform teams. And so we want to make sure that we maintain a high degree of user quality, even as engineers are moving quickly to ship code. And last but not least, the first three are all very quantitative measures, but the last one is our qualitative measure around tooling delight. So how satisfied are engineers with the tools we give them to actually go and accomplish their mission. So this is a qualitative measure that we check in on about quarterly to see kind of what are the hotspots where engineers are not satisfied with their tooling and where we could kind of improve it further. So these four areas feed into our road mapping processes. And so every quarter and every half, we're looking at these measures. We're taking in qualitative inputs from our engineers, both through surveys, but also kind of through ad hoc discussions and user discovery sessions. We're looking at these quantitative metrics and even more quantitative metrics when necessary to kind of dive into the details. and using those as inputs to understand what is the most leveraged piece of work we can do to improve the developer experience.
So one of the patterns I've noticed in many organizations is, developer experience for platform teams are generally understaffed. Like, smaller teams trying to do a lot and kind of like trying to improve productivity across the organization. How do you think about like prioritization, especially when you have uh, some of the opportunities that you talked about, sort of like long term? How do we kind of adopt new tools, adopt new methodologies to improve developer satisfaction long term versus like, okay, my bills are slow, we need to work on that?
Yeah, that's a great question. There's definitely no easy answer. I guess the good news is staffing constraints force careful prioritization. So thinking about, hey, what is really leveraged and really forces you to make the most of your resources. So I'll say it's a little bit of both. I think for a long time, we've been focused on putting out fires, fires being like really, really bad, blatantly obvious pain points with the developer experience. And kind of as we've put out some of these fires, it's allowed us more opportunity to continue investing in kind of short-term wins, but also creating bandwidth to invest in some of these longer-term initiatives and longer-term improvements to kind of get ahead of some of these fires and scaling problems going forward.
Awesome. Okay, let's dive into the a bit more meat of this conversation. So, sounds like Asana is predominantly a TypeScript shop. So, maybe share a bit more about like the current stack of the technology, and we will obviously start with learning a little bit about like history of Bazel, specifically at Asana. How long you folks have been investing into it? What's the current maturity level of Bazel adoption? And are there like even technologies outside of TypeScript that you folks use?
Yeah, that's a great question. So we've been both very early adopters of Bazel and TypeScript. So for context, I think Bazel was open sourced in about early 2015, and by the middle of 2015, or even towards the end of 2015, already one of our key production backend services was being built with Bazel. So we are super early adopters there. And TypeScript, similarly, I believe within a year or two of TypeScript being released, it was being adopted internally at Asana. And so we were both have found a lot of value in these technologies, but have also experienced a lot of friction with being early adopters of both. So specifically diving into Bazel, we adopted it so early because we were just having challenges with our previous build tools. It was a combination of using Gulp for some of our web repositories, but also kind of a lot of ad hoc scripts that many people might be familiar with that kind of have built up over time. And there's a constant series of bugs and performance issues and correctness issues that led us to be really excited about Bazel when it became an option for us. And so kind of as we incrementally started using Bazel more outside of this initial first backend service, and kind of as TypeScript also kind of naturally grew in its adoption throughout the company, we began using these two technologies together, and it's really just grown from there. I think it's now a core part of the build stack at Asana. And so most engineers are writing TypeScript code, and pretty much all of our production services in TypeScript and other production services are all compiled and tested with Bazel.
So, what percentage of developers do you think, if you were to guess, use TypeScript today internally? And and what does the rest of the folks do?
Yeah, it's probably 90% plus of product engineers are
Wow.
interacting with TypeScript in some form or fashion, and the rest are working in several other languages. Scala, for example, is another one of our pretty sizable languages used for Asana, the product. And really where we have found a lot of value in Bazel is being able to orchestrate builds across multiple languages, being able to do extensive code generation in multiple languages, and having a unified build system across the entire stack means that a Scala engineer is able to quickly compile some of our TypeScript code base in a front end. TypeScript engineer is able to go quickly make a contribution to our Scala code base because we've unified the tooling stack, the testing stack, which is really one of the features of Bazel that we really enjoy.
Amazing. So, share a bit about like the maturity of Bazel today internally at Asana, especially for TypeScript. Let's kind of like, I think that's also fairly unique and interesting because There is also a lot of new modern monorepo build tools that have come up. I think Turbo Repo, NX, those are some of them. I would imagine when you folks started using Bazel, there weren't really like that many options. Um, but I think it'll be interesting to learn how have you seen the scale of Bazel, like maybe since you started working on at Asana, especially in the build tools team, like what have been sort of like some of the big challenges that you have addressed with Bazel, and what's the maturity of it today?
For sure. Back in 2015, when we first adopted Bazel, and kind of as we first used it for some TypeScript use cases, our kind of maturity in stack was very naive. It was kind of the really a minimal viable implementation of kind of trying to get things to compile. Over time, we kind of grew in maturity and understanding how best to use these tools to build and compile things, but also kind of best practices around how we expect product engineers to interact with them as well. So we've grown a lot in our maturity of understanding, like, hey, the build teams and the developer productivity teams really love these things. But Bazel also has a lot of rough edges, and TypeScript has some rough edges as well. So we've grown a lot in our maturity of understanding, like, hey, what is the right amount of stuff to abstract away from most engineers that are just trying to make some basic changes to the product? What is the right kind of knobs to expose, and what are kind of the knobs that we should kind of tune and tweak under the hood ourselves without kind of exposing all of the complexity to product engineers as well. Over time, we've also grown in our adoption of a lot of the features that make Bazel really powerful and kind of deliver on its promise of fast and correct. So initially, we were just using Bazel without any of the remote caching and execution capabilities. And over the years, we first adopted Bazel remote caching, and then even more recently have adopted Bazel remote execution. And it's an understatement to say how much just compute time and developer experience time this saves us, both for local builds and for our CI builds. I believe for our CI system now, we're saving the equivalent of 150 years of compute time each month by reusing Bazel build artifacts. So over time, we've kind of grown a lot in our usage of kind of using Bazel to its best practices, but also really understanding, hey, what is like the right user experience to expose product engineers who maybe don't want to be build systems engineers to be able to, use Bazel enough to get their thing to compile and to run without kind of forcing, a front-end engineer to also become a build systems expert.
Interesting. So that was an interesting number. So 150 years, you said, of build time.
Yeah.
Can you maybe like explain from the perspective of if you were not using Bazel today as a developer? I mean, if you were to ballpark, like how much time it would take to build, and what is an average build time today? I understand, like with Bazel, it's like also depending on how much you modify and you build different aspects, but maybe you have sort of like an average, mean, or median build times that you track.
Yeah, so kind of going back to these key metrics that I talked about at the beginning, kind of some of the key metrics we look at is both how long does it take for someone to kind of locally compile kind of minimal change to the application. So someone's kind of adding one or two lines and they want to rebuild their change and kind of see the state of the world reflected in their local developer environment. So our goal there is that build times should be kind of on the order of seconds. And for CI, we kind of look at P50, what is like kind of a median CI build time look like? And there we kind of target about a 15-minute build time budget, and kind of within that, sometimes that grows and we kind of reevaluate, like, hey, what is the right set of things to be running in CI? So I think that is much more of a kind of a target that we shoot for, but sometimes builds are much, much faster and sometimes builds are much, much slower. The kind of neat thing about Bazel is that if you were to kind of check out our main branch at any given point in time and say, hey, compile everything and run all the tests, it would be pretty darn fast because of remote caching. So you'd be able to reuse kind of these artifacts that were kind of run by someone else.
And when you say 15 minutes is your P50 targets, does that include build and testing? I'm assuming like with the remote caching, you can also like cache tests with Bazel.
Correct. So this is like you open a PR and you are kind of running with Bazel. We're kind of using the Bazel build graph to understand, hey, what are the relevant tests that need to be run? What are the relevant artifacts we want to make sure still compile after your change? And so we're kind of using the power of the Bazel build graph to kind of only rebuild the minimal set of things and also using the power of remote caching to make sure that we're not redoing work that we don't need to redo, and then also using remote execution to kind of parallelize this work across many different workers as possible, kind of all in the name of creating a great and speedy developer experience.
So tell me, like from a maintenance perspective, what is a typical day to day like? What are some of the core challenges that you are working on a consistent basis? And also, like, how has the interaction been with like product engineers? Like, how often do you have to kind of like collaborate with them to solve a specific problem?
Bazel is definitely a very complex tool. It's a very powerful one, but that power comes with a lot of complexity. And so a lot of kind of the build systems team is trying to work through that complexity so that everyone else in the organization doesn't need to. So learning about the best practices of Bazel, but also learning about the best practices of these languages that we're integrating into Bazel, and making sure that things are set up so that they're performant and reliable. And so other engineers in the company can kind of just build and run things without needing to learn about the nuances of build systems. And they're kind of exposed a very easy way to interact with all these things. So a lot of maintenance and work is kind of trying to push on the adopting best practices to get kind of the best possible performance. Especially as the ecosystem evolves. Like TypeScript nowadays versus TypeScript 10 years ago is a completely different beast. So over time, we've kind of incorporated a lot of, the latest tooling into our build system and into kind of the systems that we expect product engineers to interact with. And focus a lot of our time and energy on kind of keeping things as performant and as easy to use, even as the organization scales. And then you also asked about, hey, what does working with product engineers look like? One of the exercises we found most valuable when trying to understand the product engineer experience is to sit with them for an hour or two as they work on a task, really shadowing them and trying to live a few hours in their life. And it is shocking and surprising the things you will learn. Things that you thought were fast enough suddenly seem excruciatingly slow as you see someone kind of twiddle their thumbs waiting for a build to complete. Things that seemed so obvious or so easy to use suddenly don't seem that way when you kind of watch a product engineer struggle trying to figure out what is the right set of command line options to pass to a tool you built. So a lot of our work is trying to reduce those frictions. So trying to make those things fast, trying to make those things easy. And this exercise of trying to shadow someone for a few hours can be a super enlightening exercise to understand what the actual lived experience is like using the things you've built.
So, what do you think has been the most surprising thing about Bazel? Like maybe certain thing which feels either too easy and was really hard with Bazel, or something which was probably the other way around. Maybe something which we expected was really hard and turned out to be relatively easy.
Yeah, that's a great question. So something that ends up being surprisingly hard or tricky is things that want to maintain state. So for example, you might be familiar that the TypeScript compiler and some other kind of compilers have an incremental mode where they maintain some kind of cache of artifacts that they want to reuse on the next build to kind of speed up local iteration. This kind of thing is really tricky to get working with Bazel because it has such an emphasis on hermeticity and correctness. So using things that have some kind of incremental mode can end up being quite frustrating compared to kind of the non-Bazel experience. On the other hand, features like remote caching more or less just work a lot of the time, and it's super powerful when you're able to pull down your kind of colleague's branch and the build artifact is basically available immediately because it's been remotely cached.
Interesting. And you've been also one of the early adopters of Bazel. You said 2015, if I'm correct. So, how has the evolution of Bazel been for you? Like, did you have to upgrade Bazel system itself? I understand like Bazel has also gone through a lot of changes over time. Have they been always backward compatible? Like, what have been your experience using Bazel for that many years?
Yeah, so we adopted Bazel and TypeScript both before they had hit their 1.0 release. And so, there's been a fair amount of maintenance and upgrades associated with adopting these technologies so early. So yeah, as the kind of ecosystem has evolved, so have we. I think it's all definitely been for the positive, though. For example, more recently, there's been a big push in kind of the JavaScript TypeScript ecosystem to kind of adopt Rust-based tooling to replace kind of JavaScript equivalents for performance. And so that's also been a thing that's been, kind of an evolution in the ecosystem, but has been worked quite well for us because with Bazel, it's quite easy to kind of pull in a new tooling into the build system. Because we've kind of abstracted out the right amount of stuff from product engineers, we're kind of able to make these kind of pretty large sweeping changes without anyone really noticing their day-to-day workflow impacted too much. And because of these kind of guarantees around correctness, it's pretty easy for us to kind of make these changes. And because we kind of expect product engineers to be using Bazel as part of their local builds, we don't have these problems around like, hey, it works on my machine, but it doesn't work on your machine. We're kind of able to introduce these big tooling changes, and it pretty much just works on everyone's machine because everyone is using Bazel to compile.
Let's say if you were to give advice to folks who are just considering using Bazel for TypeScript, what would be your recommendations? How do they start? Where do they go from there?
Yeah, that's a great question. I'll say, even though there's a lot of benefits, the community and ecosystem around it is not quite large. And so you get some very specific benefits, like I've described, but there's also a good amount of trade-offs. And so I'll say for most companies and projects, if you're looking to evaluate these two technologies, it could work for you, but of course, there's also going to be a lot of trade-offs. I think for us, because we so heavily rely on extensive code generation and lots of cross-language dependencies, I think we would use Bazel again, even if we were to start from scratch, because kind of more ecosystem-specific tooling just for one language doesn't have the kind of same extent of capabilities that we've come to rely on.
Interesting. Have you ever evaluated or looked into like the other tools that I mentioned earlier, like Turbo Repo and X? I think are the two more modern tools, which I think are also predominantly focused on front-end like TypeScript languages. Mm-hmm. What's your opinion on those?
Yeah, we definitely have evaluated language-specific tools like Turbo Repo and X. I think because we employ code generation, like we're generating millions of lines of code and generating millions of lines of code in different languages, and rely so extensively on kind of Bazel's ability to, as a polyglot build system. Migrating would probably have a lot of complexity and kind of still require a fair amount of kind of handwritten scripts to tie these various tools together. So it's definitely something we've evaluated, but kind of don't see enough upside currently for our use case compared to the migration cost. But that doesn't mean they aren't good tools and won't work for others.
Got it. Is there a place where you think somebody who's considering adopting Bazel versus Turbo Repo, for instance, or like any other tool rather, what do you think are some of the aspects that one should consider?
Yeah, I think trying to understand exactly what you're trying to get out of it. Is it the remote caching and execution capabilities? Is it the correctness that you're most excited about? Is it scaling problems that you're trying to solve? I think trying to understand what problem you're trying to solve can be really helpful in understanding like what is the right tool for you. And I think there's also pretty sizable like online communities of people that have adopted each of these tools for very different use cases. And I would encourage kind of reaching out to these communities to kind of understand if your use case is a good one for that specific tool.
And speaking of communities, what are your favorite resources to learn about Bazel? Kind of like where things like, I mean, are there communities? Are there like blogs or any other like resources where you learn the most modern practices about Bazel?
Yeah, there's a pretty active Bazel Slack community that I encourage people to join. And there are specific channels for each of kind of the language ecosystems and about kind of Bazel best practices in general. And that's both really a great community, both for Bazel experts trying to look to connect with others, and people just getting started and trying to understand how to compile their first application with Bazel.
Very cool. Thank you. And I'll probably put a link of that community in the show notes as well for people to access it. So share a bit about like your roadmap, right? I mean, what are some of the things that you're working on now, given that Bazel has already been adopted for like 8 years now? So like on a day-to-day basis or like sort of like long-term basis, what are some of the core areas that your team focuses on? within Bazel?
Yeah, so one of the kind of big trends in the JavaScript TypeScript ecosystem is kind of like a next wave of tooling written in predominantly in Rust and Go that is kind of just like much faster alternatives to kind of legacy or somewhat legacy tooling. So a lot of our work recently has kind of been evaluating some of these newer tools, for example, like SWC, ESBuild, um, to kind of evaluate whether it makes sense to adopt them and kind of whether it makes sense to integrate them into our happy path of our Bazel TypeScript setup to kind of even further improve performance. So, like I said before, that like build times can be on the order of seconds, and that's like pretty fast, but our engineers also have very high demands. And so our goal is to always kind of be moving the needle there and keeping very, very fast build times so engineers can stay in flow, even as the size of the application, the complexity of the application, the interconnectedness of our application grows.
Awesome. Well, thank you so much, Eric. We do have now time only for rapid fire, so maybe we can quickly switch over to that. And so, are you ready for the rapid fire?
Yeah, let's do it.
All right. So, tell me areas that you're most excited about in the developer experience space as a whole, like anything specific.
Yeah, it's cliche maybe at this point, but I'm really excited about the role of LLMs and how that will kind of impact pretty much all facets of developer experience in the years to come.
Nice. So maybe you can share about more about like LLMs and what's your take on Copilot, and outside of Copilot, what are the use cases of LLMs maybe you've explored or thought about?
Yeah, Copilot is definitely a pretty neat tool. I think engineers are saying that it's making them definitely a little bit more productive. Maybe not quite the 10x developer productivity gains we'd hoped for just yet. But I think in the years to come that LLMs kind of in some shape or form will be impacting almost every part of the developer experience, from how we write code to how we review code to how we kind of evaluate code for bugs, how we do tests. It's really seems like there's opportunities for AI to play a really big role in almost all parts of the software development process. And I think a few years from now, we'll look back on kind of our current set of AI tooling, and it'll be shocked at kind of how far it's evolved and how we'll eventually begin to realize some of the hopes and dreams around kind of the extent of the developer productivity gains to be had.
So, coming back to like developer experience and platform engineering, what do you think makes a good platform engineer or a developer experience engineer?
Yeah, I think a great developer experience engineer needs to be both very empathetic and have a knack for continuous learning. Uh, Empathy because our customers are other engineers. It's the people that we work with. It's the people we have lunch with, that we talk to every day. And so I think having a great ability to empathize with them can be super powerful in building fantastic experiences for them. And also the ability to just be continuously learning. The ecosystem continues to evolve so quickly, and things are changing once again with the kind of advent of LLMs and kind of their integration into all parts of the software development lifecycle. And so I think kind of both having that ability to empathize with our customers and the ability to kind of always be learning the latest and greatest really makes for a great developer experience engineer.
Awesome. And are you folks hiring?
Yeah, we're definitely hiring asana.com/jobs if anyone's interested.
Nice. I'll post a link of that also in the show notes. And the last question: Are you? Do you recommend any books?
Yeah, a book recommendation that I frequently find myself going back to is The Design of Everyday Things by Don Norman. At the end of the day, a lot of engineering problems and especially developer experience problems come back to design and people problems. And I think kind of cultivating that side of our technical brain can be really helpful in empathizing with our customers.
Nice. Yeah, that's also one of my favorite books as well. So, thank you so much, Eric. This has been a pleasure. Really enjoyed this conversation, and look forward to seeing you at other Hangar DX sessions. For folks who are joining for the first time, we also run a Hangar DX community where you can meet people like Eric, also to learn more about some of these best practices. Thank you so much for your time, Eric, and have a great day.
Thanks so much. It's been a pleasure chatting.